Here is question 2A, part 2. So the question's looking at comparing significant features. So when we think about significant features, I want you guys to automatically think shape, centre, spread. Those are the three absolute key ones. There's others such as shift and overlap and unusual features, and those ones are useful, but the three main ones that you must do are shape, centre and spread. So we've got data on the age of athletes and swimmers at the Olympics. So we're going to start with looking at the shape. So I'm just going to draw over the top of the distribution there, and to me that looks like it's right skewed. There's a little bit of more of a tail on that right hand side that we can see there. Another way to think about that skewness is if I've just drawn a line in the box plot at the centre, the median. If you look at the distance from the median to the bottom, to the minimum, and the distance on the other side, if those two distances there, the one on the left of the median and the right of the median, if they're approximately the same size, then it's fairly symmetric. This one's not, so again it's backing up. There's a longer tail on the right hand side. Now let's have a look at our swimmers. And again, when we draw that shape over the top, it looks right skewed. And I'm going to confirm that looking at the median and the distance to the left of the median versus the distance to the right. And those two arrows are not the same size. The one on the right is definitely longer. So again, that's backing up that it's a right skewed distribution. So we're going to write ourselves a little sentence. So we notice the shape of the distribution of ages, all in context, of Olympic competitors in both athletics and swimming are right skewed. Make sure you justify it. So first of all, notice, then justify it. So it's because they've both got a longer tail on the right hand side. Or you can talk about there being the data more compact on the left hand side and more spread out on the right. There's a number of different ways that you could word that. Okay, so that was looking at our shape. Our next one is our centre. So what we're going to do is we're going to look for, and I've just drawn a line going down there for the centre of the athletics, the ages of athletics competitors. And I can go to my table, and I've just circled there the median age is at 26. So that's what I know. And I've just put that on the box plot to show you visually. Then we're going to do the same thing for the median age of the swimmers, and we can look on the table, and that's got a median age there of 22, so we can also put that on there. Now what we're looking, and you can see I've drawn this little arrow here, we want to look at how different they are. That's what we're looking for, is we're comparing. So we want to know which median is bigger by how much. So the difference between the medians, if we do 26 minus the 22, that gives you a difference of 4 years. Now, which one is bigger? Well, the median age of athletics competitors is bigger than the swimmers by 4 years. So what we want to do now is write that up in a sentence and then justify it, give our evidence of it. So we can say the median age for athletics competitors is older by 4 years than the median age of swimming competitors, and I'm giving the population for competitors at the 2012 London Olympics. Okay, so I've highlighted some key words we need in the sentence. When we're comparing the centre, we must be looking at the median. We must talk about the two groups. In this case, we're talking about the athletics competitors and the swimming competitors. We must say which median is bigger. And this one, the median of the athletics is bigger by 4 years. And then my justification, because the median age of athletics competitors is 26 and the median age of swimming competitors is 22 years old. So that's my evidence or my justification and proof. So we've done shape, we've done centre. Now we want to have a look at spread. Now I've just drawn two little arrows there on my box and whisker graph just above them. And what I want you to notice is those two arrows, that's what we are comparing, because we're having to compare the features So we're comparing the spread, and we want to know, is this the spread of the athletics ages similar or different to the ages of the swimming competitors? So those arrows I've drawn are to represent the interquartile range. So what I want to do is, first of all, for the athletics competitors, I want to look at what their lower quartile is, and so I can look that up on the table there, and that's a lower quartile of 23 years old. Now I'm going to do the same looking at the upper quartile, and that's, I've just circled on the table, that's an upper quartile of 29 years old. So that gives us an interquartile range, and remember this is a formula you'll need to know off by heart. Interquartile range equals upper quartile minus lower quartile, so our 29 minus the 23 gives us 6 years. So that tells us the interquartile range for athletics competitors is 6 years. Now we're going to do the same process with the swimming and look at what the interquartile range of swimmers are. So I'm going to look at what the lower quartile there is, and so that's got a lower quartile of 20 years old. Then I'm going to look at the upper quartile, and that's an upper quartile of 25 years old. Then I'm going to find the interquartile range. 25 minus the 20 is 5 years. So now we've found the interquartile range of our swimmers and athletics competitors. And now what we do is we write a sentence comparing those. So you can either say that they are very similar spreads, or you can talk about the athletics competitors are slightly more spread out than the swimming competitors' ages. Okay, so make sure I'm talking about the ages, I'm talking about it in context, and I'm giving the population, the 2012 London Olympic Games, that's where my data comes from. So I need all of those things. And then I need my justification. So it's because my interquartile range for athletics competitors is 6 years old, 6 years compared to the interquartile range for swimming competitors, ages of 5 years. So I've got my proof. Let's have a look at how we mark this then. So if you're able to do one comparative comment, so you just did this shape, for example, you compared the shape and you said that they are both right skewed, and you talked about it in context, then that would give you a U, an understanding or achieved level skill. If you could do two comparative comments, so for example the shape and the centre, and you needed to compare them, which median is bigger by how much, etc., then that would get you an R, which is your merit level. If you're able to make three comparative comments about the three features, shape, centre, spread, then that would get you through to excellence.